Good morning, everyone. To begin our presentation, I would like to introduce the role of steam power in energy generation and industry. Steam power plants play a vital role in global energy production as well as various industrial processes. Essentially, they work by converting the heat energy of steam into mechanical power, which is then transformed into electrical energy through a generator. Now let's look at a few key points about steam power. First, its wide application. Steam power is not limited to electricity generation. It's also widely used in industries such as paper manufacturing, food processing, ship propulsion, and even building climate control systems. Second, dependability. Despite the rapid growth of renewable energy sources, steam power plants continue to be highly valued because of their reliability and ability to operate continuously for long periods. And finally, the core process of steam power generation is based on what we call the Rankine cycle. This is a closed-loop system where water is repeatedly heated to produce steam and then condensed back into liquid form. This cycle allows efficient and consistent power generation. In short, steam power remains an essential and dependable source of energy that continues to support both industrial operations and electricity production worldwide.
My name is Ahmad Raja Asmawi Benzel Fazli. My metric number is 01DKM23F1012. Next is the key component of a steam power plant. A steam power plant is a system that converts heat energy from fuel into mechanical energy and finally into electrical energy. It mainly works on the Rankine cycle, which involves heating water to form steam, using that steam to drive a turbine, then condensing and reusing the water. There are four main components that make this process work efficiently: the boiler, turbine, condenser, and pump. The boiler is a closed vessel where water is heated by burning fuels like coal, oil, or gas. Inside, the heat converts the water into high pressure steam. This steam carries a lot of energy which will drive the turbine. So, the boiler main function is to produce high pressure steam for power generation. Turbine. The steam turbine converts the steam's thermal energy into mechanical energy. When the high pressure steam flows through the turbine blades, it makes them spin. This spinning motion can drive a generator to produce electricity. So, the turbine is where energy conversion from heat to motion happens. After passing through the turbine, the steam loses its pressure and becomes used steam. The condenser cools this steam and turns it back into water called condensate. 4. Finally, the pump takes the condensed water and sends it back to the boiler. This completes the Rankine cycle and keeps the system running continuously. Additional notes: modern steam power plants also use accessories such as economizer, air preheater, and superheater to improve efficiency by reusing heat and maximizing energy output. And to short them, these four main components, boilers, turbine, condenser, and pump, work together in a continuous cycle to convert fuel energy into electrical power efficiently and sustainably.
Assalamualaikum. My name is Aina Confiras Binaras Fazila from DKM5A, and its number 01DKM23F1001. I will explain about the differences between fire tube and water tube boilers, directly create their unique safety priorities. The fire tube boiler, with its large shell full of water, is like a sleeping giant. It stores a massive amount of energy, making it slower to respond and at a higher risk for catastrophic explosion if its pressure limits are exceeded. Conversely, the water tube boiler, while safer and faster, operates at much higher pressures, meaning any weakness in its tubes or drums can lead to a rapid and violent failure. Therefore, the safety protocols and inspection are not just generic rules, they are tailored responses to the specific dangers inherent in each boiler's design. Next, boiler safety and inspection. Regardless of their internal design, both boilers rely on the same fundamental safety philosophy: proactive vigilance. This is where regular inspection and safety devices become non-negotiable. The inspection process acts as a doctor performing a physical, specifically looking for a corrosion in the fire tubes, large shell or scaling inside the water tube intricate pipes. Meanwhile, safety devices like pressure gauge and relief valve serve as the universal guardians for both systems, ensuring neither the stubborn pressure in a fire tube nor the intense pressure in a water tube can ever climb to a dangerous level. This shared commitment to prevention is what allows us to safely harness the power of both the simple workhouse and the complex powerhouse.
My name is Adam bin Hasni, matric number 01DKM23F1011. So now moving on to number 4, which is heat-saving instruments for efficiency. So these instruments recover and utilize waste heat, contributing to sustainable energy management by reducing fuel use and emissions. So the first instrument is economizer, which uses exhaust gases to preheat feed water, significantly reducing fuel consumption. Next is air preheater, which preheats the air entering the furnace using residual heat from exhaust gases. Then is the superheater, which increases the steam temperature above its saturation point, which improves turbine performance. And lastly is feed water heater, which raises feed water temperature to minimize thermal shock and boost overall efficiency.
My name is Ali Farahan and my matrix number is 01DKM23F1032.
For part 5, we have regulations, safety and sustainability. Steam power plant operation requires strict compliance with safety standards and a focus on environmental sustainability. Regulations comply with local and international standards, while safety procedures with emergency plans and staff training programs. For sustainability, emissions control and resource efficiency measures. Okay. Some example. Number 1, for regulatory compliance, we have following local or international guidelines, including boiler pressure tests and emission control. Moving on to the next one, safety protocols. We have pressure monitoring, emergency shutdown system, and regular personnel training on emergency response. And lastly, we have sustainable practices, minimizing fuel waste, improving heat recovery, and adopting cleaner fuels like biomass or natural gas.
Aligning with global goals. Incorporating efficient design and renewable integration support long-term environmental goals, aligning with UN Sustainable Development Goals. For SDG 7, we have affordable and clean energy, focus on efficiency and cleaner fuel adoption. For automatic method monitoring, systems detect abnormalities early and reducing accident risk and also improving operational safety. And lastly, SDG 12, responsible consumption and production, minimizing waste and optimizing resource use.
Rajab 1012. And the last part is conclusion. The future of steam power. The steam power plant remains an essential technology in modern energy production. Understanding its component, safety system and efficiency enhancing instrument is key for engineer. Key takeaways: reliability. Steam power provides continuous and dependable energy. Efficiency, heat-saving instrument are crucial for optimizing performance. Compliance, adherence to regulation ensures safety and environmental responsibility. Outlook, with continued technological improvement and responsible operation, steam power plant will remain a key contributor to global energy needs in an environmentally conscious manner. Thank you.